Welcome back, everybody. There we go. Volume's good. All right, I'm here. I'm back. We're online. I think the stream has started. So welcome. I'm Agent Ultra. This is the stream where we hack on Haskell projects of various sizes to get a feel of like what it's like to do functional programming, but like for realsies and not just for writing white papers. And yeah, I'll be your host tonight. If it's your first time tuning in, welcome. We're going to be working on LambdaTrek, as we have been for a little while now. LambdaTrek is a tiny rogue-like type of game inspired by Trek, the Trek universe. It is currently a terminal UI-based game, so I'm just going to pop it up here so you can take a look and see where we're at so far progress-wise. So if I go to the projects directory here, go to LambdaTrek, I can use my stack build tool, that's what we use here for most of our projects, to run it. LambdaTrek like this. Alright, so currently we have just wrapped up kind of the first real pass at procedural generation. So right here you see that's a space station, the $sign there. The S is our starship. We're looking at like a little kind of sector of space. These little arrows here, this is an enemy ship, and those are stars. The goal of the game is to eliminate the opposing force of enemy ships from the whole quadrant before you run out of turns, or your ship gets destroyed, or you run out of energy. All right. You have a lot of tools to your advantage here. You've got shields and torpedoes, and you can fire lasers, things at your enemies. And we have a little sector map. So, a quadrant map here. So you can go here, you can use your long-range scanners to like scan different quadrants or different sectors in the quadrant. Of course, we are currently being attacked because we're close enough to an enemy ship that they can hit us. We can warp to different sectors. We're in the middle of implementing a settings screen. But I haven't done the research yet on if it's even possible to do multiple forms in a brick application. So I don't know how much time we want to spend on that. I think the easiest workaround for this right now is just to load our settings from either the command line or from a settings file until we can figure out the UI screen and the multiple forms thing. And that will just allow us to tweak some of the procedural generation parameters so we can control how many enemies get generated, for example, in our game, how many space stations there are, so on and so forth. And let us kind of tweak those numbers so we can get a good feel for our fun factor of the game, I guess. And yeah, maybe we'll add a little bit more to that over time so you can tweak things about the ship and stuff, but let's start with that as a kind of a starting point. So I'm going to go over here, I'm going to go to LambdaTrek, I'm going to bring up my editor and get things kicked off there. Okay, we'll get our build tool going. So we use stack, build, fast with file watch. Resized a little too much. There we go. That's looking pretty okay. Come on. Come on. All right. There might be a couple of other little things we need to do here. Oh, we did that. That's done. Yeah. I don't think we've actually done that, so we might need to do that. Some text wrapping to the dialog area widget to polish up. Yeah. Okay, so let's do the settings file. I guess we could do it from file. Or see if we can do it from command line. let's break this up. Let's do multiple of these because it might be more convenient that way. But we're gonna just start with command line. And from the file, and then from an in-game form. And maybe the in-game form can persist those settings to the file, which we can read from on startup, and yada yada yada, and that'll all tie together nicely. But let's just do the command line for now, because that'll be quick and easy. Okay. So in order to do that, we're gonna have to go to the top level of the entry point of our program here, which is run, and parse our command line arguments from there. Fortunately, we can do like this silly simple way and just parse them on our own, but there's a pretty decent little Haskell library you could probably pull in for this. It's quite lightweight and nice. It's called opt-parse applicative. Begir. Alright, so if you're making command line apps in Haskell, this is a pretty popular library. A lot of folks use it. It's pretty good. And we're going to use it too. So I'm going to go over to my packages, or my Cabal file, whatever I'm using. Packages. Package.yaml. There we go. Under my dependencies for the library. Yeah, we'll add that here. Applicative, boom. Okay. So, basic introduction, you just import it. Give it a little type with your arguments. Create a parser for it. Kind of very similar to like other parsers we've seen, like applicative style parsers. Even that we use in the game engine for this game here, where we're parsing commands. Very similar structure. You got your functors, you got your applicatives. And there's the different parsers for the different options. And we return a parser. So I might actually go and create that under CLI. And we'll just go. Now we're going to fill in. Before I go running data structures. LambdaTrek config. Okay, we want to fill this in. With our thing. We want to create a parser for this. And for now, let's just target number of enemies just to get it going. So we can either, well, we might want to put more configuration in there than just the game config thing. So let's create a new data structure for it. What to call it though? I'm running the risk of actually, if we're going to do the file thing as well, duplicating our configuration across them. So I think game config is the one we want to stick with. I'll create parsers for that. The only thing I want to avoid, I might run into with this is just getting into a circular import, but we'll see how that goes. LambdaTrek, .config. Yeah, okay. So we're going to create a parser just like this. CLI, we'll call it CLI parser. parser of game config. And we create our game config over top of that, right? Like that. Game config. Reaching into our parsers. So for ints, we probably have like an int parser. Metavar int option auto. Where's the different parsers? Basics. Okay. String option. Input. Okay. Maybe it is just auto. Long, I guess, means the long option name. Yeah, okay. I think option just means optional. And we have a default one. Okay. Okay, so let's try auto. And when we combine the options together for this field, this. The formatting is going to be a little bit weird. We'll figure it out. And let's go. Let's say the opt should be num enemies. Like that, maybe? Okay. You gotta have help. Number of enemies to generate. Go default. Default. Say 20. Or value 20. And metavar. That's for display purposes. And then maybe this will tell us what our problem is here. Could match type int to gamefig because we haven't finished filling in all the fields for gamefig. But our parser is going to want everything here. Actually, these should be all optionals, yeah. So, and we'll give them all defaults. That seems like the way to go. Okay. Lots of enemies per sector. Maximum number of enemies to place per sector. And go default value, let's say 4 of our One more. And num stations. So 2. Okay. Indent that a little bit. Kind of form. That's okay. Not sure I like the formatting of this, but it's readable enough. Kind of shows you what's grouped together, at least by the indentation. Okay. All right. So we got that defined. Now we should be able to hook that up to the entry point of the program. LambdaTrek, CLI. And then we need a runner. So exec parser, probably the easiest to use. And then these, when exec parser pure. Okay, we gotta handle those, but exec parser will do that for us automatically. I see. As long as we're in IO. We might as well use that here. All right, and our CLI parser, we called it. That'll get us our game config. That there. Needs a parser info of a. Okay. So that's the info function. Okay. Opts. No, that's commands. Info something. What's that? Whole, that's the parser. Okay, what's this? Info mod. Brief desk, forward options, full desk, empty, IBM. I'm just looking at the valid whole fits. I'm not really sure. Let's go with brief desk. Brief. I assume that means brief description. All right, and then instead of default config, we pass in game config here. Okay, we don't actually need import config here. Super. So let's test out how that works. Let's see if it goes. Okay. exact LambdaTrek. Right, we got the defaults. Let's see if we can pass in help. Okay, there's our options if we want. I guess there's a way for us to provide help as an option, but there you go. So we should be able to apply none enemies. Let's do something like 100. Interesting placement. Alright, we do fully random placement here, so as long as they're not on the same space. So side by side is fine. There could probably be a better algorithm for that. So if they're kind of like spread out in the sector or like in kind of formations of some kind or another. Let's try like, where are we? LRS 0 and 3. So space station up there. Let's warp there. And we warped in here. Ooh, lots of enemies. 1, 2, 3, 4, 5, 6, 7 enemies here. Looks like we got some spillover. And try 02. We wanted a 4. We got a 7. I think our algorithm will supposed to actually respect that value. So let's go double check that that's is the case. Quadrant is where we have the generate module that generates the quadrant data, which is where we derive all the like individual sector datas and stuff. All right, generation enemies max, the maximum number of enemies to place in the quadrant. All right, so if we go to generate add sector any. Alright, we get the generation state. We try to add the enemy. Couldn't. We do nothing. Otherwise, we return just the enemy. And update the quadrant data. Okay, and when we go to generate enemies, place enemy ships. So we calculate enemies max. Alright, so we take the minimum value of generation enemies sector max and generation enemies max minus the count. So the remaining enemies that we've placed so far. Whatever the least of those two numbers is. So it could be 4. Most of the times it'll be 4. And then occasionally it might be the maximum number of enemies we want to place minus the current count. That could be less than 4 current number of enemies we placed. And then so we generate a number between 0 and that. Okay. And in generate enemy ships, that's for a particular quadrant. Or sorry, a particular sector. We get the enemies count. That's the number of enemies we've placed so far, which would kick off as 0. For each of the quadrant cores, and we basically I see. So we will get some spillover. So we define a high number of enemies, but we say we only want 4 per sector. This will we will place all of the enemies, but this algorithm will go over the maximum number of enemies per quadrant, because we go quadrant by quadrant here. And we could wrap around in the sequence since we cycle and keep placing. So it's not maximum numbers per sector necessarily here, it's like maximum number of enemies to place at a time. So could be some multiple of 8 or like something just slightly less than that multiple of 8. Depending on how many times we cycle through the quadrants. We could update this so that we skip placing enemies if the sector already has the maximum number of enemies, and that would just mean that we'd also have to track our base case for terminating this, because we might not be able to place all of the enemy count that the user has asked for. So what I'm thinking is maybe we do that in a separate step. Yeah, we'll do that separately. For now, I'm gonna comment out these parts. We'll add those back in at a later date. We'll just go here, say 4, and here, say 2. And so we'll just parse fixed values for those. So that's built. Now if I try my helping, it's just the num enemies. Okay. That's better. Okay, cool. Alright, so we get lots of enemies here if we choose 100. Or we're going around and we're just leaving enemies per sector kind of right now as maybe like an implementation detail of our algorithm. Maybe we want to expose it to the user and then like do some things to make that actually enforced, so it does what they expect. But yeah, that's probably good enough for now. Put a little to do in there. Well, we might want to expose number stations. There's no harm in that one. But we also probably want to put limits on these too. I wonder if there's a way for parse applicative to put validation functions on these, or we should write our own validation separately. That would probably be the easiest. Or we can even give short ones for that, that'll be handy. Short E. That'll be nice. Yeah, shorty. Oh, that's a car, sorry. Okay, well. Yeah, I kinda like num stations. I'm gonna uncomment that one. Bring that one back in. Short S. Okay. Yeah. Let's go commit point. I'm gonna stage that. See. I'm gonna mark it work in progress though, because I want to do the validation part. Next. Add CLI game config parser. Okay. Validation. Let's put that in config. Valid config. Give it a game config. Return either string or I don't know, text or game config if it's valid. Simple, easy, straight to the point. More text there like that. Okay. So the number of enemies should be within a certain range. Let's pull, actually before we do start writing the terms, let's get the argument in. Config, actually, because this is on the left-hand side of the arrow and on the right-hand side, although it's within the either, that might cause problems with record wildcards, so I'm just going to put it as config, game config. It's config. Yeah, we'll do it like that. Key, and then I'm going to lose my editor for some reason. Not sure what happened there. Very comforting. Okay, so yeah, we'll just have a couple little functions for just checking those things are within reasonable ranges that we want for our game. You're under game config. Just config. Alright, valid config. Lost all of them, that's weird. Okay, let me get back to where I was then, for some reason. I didn't even come back up with everything recovered. Okay. Import data by text, boom. Valid config. Okay. And enemies. Come in. We'll call it in range to must number of enemies must be between 0 and I don't know, let's say 255 for no reason. And we'll get config game config num enemies. And then we can turn game config num enemies. So we just need to find in range. Alright, that'll take text, an int either text or int. Actually, we probably want to define what the range is, so let's do int. And just like that. That's weird. Anyway, num enemies. Yeah, I'll just give like 0, 0, 0 to make the compiler somewhat happy. We got a type error here. Expect to type either text int and config C0. Dot is applied to too many arguments. Okay. Oh, overloaded record dot. That's a pretty newish language extension that was recently added to Haskell. I mean, if you've been programming Haskell full time, it's probably not that new to you. And if you've tried Haskell before and you bounced off of it, it's probably pretty new. The dot now has probably too many uses in Haskell. Because like this, it's overloaded record dot when you have that language extension enabled. When it's like this, it's got spaces around it, it's function composition. What are we even doing? And then, of course, we needed overloaded strings. Okay, now we're good there. We can implement in range. That's error message, range, yeah, and X. I'll just pull that apart as like low, high. I'll say X is greater than or equal to low, and X is less than or equal to high. Then return pure X. Otherwise, return left error message. Cool. All right. So we're defaulting a number of enemies per sector. And we could do stations as well. Must be between, say, 1 and 5. And config.game config num stations. Do num stations here, and I'll just do config dot config enemies per sector. Super. Okay, so there's our validation. That's probably going to go into our main module. Okay. And so I'm going to pull in config again. And for LambdaTrek.config. And we'll use that here in our case. Valid config of game config. Left. There, something right. Config. And we'll just push all that block in there. This will be big. So in the error case where we don't have a valid config, we should in the error message, and is there a way for us without parse applicative to just display the help? Let's run the parser. Let's look into, where would it be? Maybe the top level. Parser info describes a command line program used to generate a help screen. Okay. 2 modes. Help are supported, brief and full. In brief mode, only an option and arguments will be displayed, while in full mode, each available option command including hidden ones is described. So we create it with the info function and set up info mod modifiers, and can we display it? It's not, okay, it's not necessarily a parse failure. I just want to display the result. Redisplay the help screen. But I don't want to handle any parsing. Show help on error. Press mods, no. Parser help. Maybe not, no. Maybe it's in extra or common. One parser info. Maybe that's what we want. Maybe that's what we want, yeah. Yeah, maybe that's one. Okay, let's try this one. Run parser info. Alright, that takes a parser info and some args. Which is a list of strings. We'll just do mempty. That's from options and applicative extra. No. Common. Okay, that's text, so I gotta convert that. Unless I data dot text import that qualified. That's text dot back. Back. Okay, run parser info. Oh, it doesn't run in IO. What does it do? It runs in MA, so monad P. Ah, rats. This is some internals we don't want to look at. You know what? It's ugly. Let's just put the error there. That'll probably be good enough. We don't need perfect. Okay, cool. So if I specify too many enemies, it's gonna be like that's actually 0 is probably not a good number, but it's there. Okay, and if we try to do a little bit more reasonable. Okay, cool. No here. Cool. There's a few here. Awesome. Cool. Move all around. There's enemies and all that stuff. Super duper. Okay. Cool, cool, cool. And that must mean that we're in a pretty good speed. Let's go commit that. Good. Application. Good. Let's rebase this. We'll squash that into that one, reword that. Boom. The ability as the num enemies and num stations options validates input num enemies between. I'm actually going to make it 1,255. And num stations between, let's say like 1 and something like 1 and 8 or something like that. Let's just fix that quickly. 1 and 5, okay. Let's make that 1 and 2 and 55, and 1 and 8. So we're truthful. We haven't pushed yet, so we can still do that. One and 8, 1 and 2, 5. Yeah, okay, good, good.